Okay, 6.3, calculating a z-score, which we're good at by now, and then getting the area under the curve to match the desired z-score area we're talking about, all right? So the mean test score was 82.5, okay? And the standard deviation was 3.0. What's the probability, also known as area under the curve, of scores being between 80 and 90? All right, so we have to build our curve first of all. Here's our mean, 82.5 in the middle of the curve always. And now here's our standard deviations, increments of 3.0. So I jump out by 3.0 every time. There's 2 deviations in each direction, and there's 3 deviations in each direction. Okay, now where's my range of 80 to 90 going to fall? Well, I need to get a z value for each of those, which is in measurements of standard deviations. So the number minus the mean divided by the standard deviation of 3. So our first one on the left for the 80 is negative 8.3 deviations. So not quite a whole deviation, but it's going to be almost 1 deviation to the left of the mean. And on the right side, I'll call it Z2, our z-score, to the right side, where 90 would fall, is 90 minus the mean, and that difference divided by the standard deviation size, and what puts us at negative or positive 2.5 deviations. Okay, and again, here's 1, 2, halfway between 2 and 3 there, and we look, and yeah, that makes sense. 90 does fall right halfway between those two numbers. So it has a z-score of 2.5. Okay, and for this one, we're going to use the calculator, but let's fill in the area just to visualize what we got there. So there's the 2 lines, there's the fill in, and this is the area. We can visualize now that's the area we're interested in seeing what percentage of the whole bell curve that area covers, all right? And again, we'll do it in the tables next, but here's the calculator and the TI-83. Some of you are bumping up to an 84 now, which is good. And it's a little different, has a few more actual features for making it very precise, but here's 83 and 84 are very similar. So I hit the second key and my distribution, which is above the vars, and here's what under vars, I look for normal CDF, and then I'm going to give the range that I'm interested in. So from negative 8.3 deviations over to positive 2.5. So I just type both of those in, and it gives me 0.7905 back, and that's what this area is up here, okay? So that was the question, was the area between these two amounts. So again, in recap, I got both of their z-scores, and then found the area between those z-scores basically just using my calculator, okay? That's if you don't have a calculator, you just want to see how to use the table. Let's do that next. So here's this one, and we'll start at the same place here. So it starts off just like the other one. The mean, we've already talked, is 82.5. Deviations we've got in there, except for the outer one. So we know those from the one we just did a second ago. And we're going to find the z-scores for the range we're interested in, which again is the 80 and the 90. We want to know how much area fits between 80 and 90% on the test score. All right, the mean was in the lower 80s, 82.5, and we're going to calculate the z values for those again, same as what we just watched. So we'll go through it pretty quick. But negative 8.3 is where the 80 falls. The 90 falls up at 2.5 deviations. Again, these are the test score values in increments of deviations. Okay, so we already know that. Let's fill in the area, and I'm just going to do it with the tables now. So here's the table from the book for the left half of my bell curve. Okay, anything that falls on the left half, basically negative numbers. In other words, I've got negative 0.8. On top of that, I add a 0.03, and where those meet is 0.2033. Okay, What does that represent? Well, both of these tables always go with what's to the left. So that's the area from the left of negative 0.83 deviations to the far left end. All right. Now I need to know where is 2.5 deviations in terms of area underneath the bell curve. And I pull up from the book and I get 2.50 and it puts me at 9938. Okay. That's the amount covered from all the way to the left over to 2.5 deviations. All right. So it might be a little misleading because this is not all yellow. This is everything all the way to the left of that line. Now we have to subtract. I take the 9938 minus this part here that I don't want to include, the 20.33% or 0.2033, and that subtraction will tell me what's in this yellow area after taking out the 20.033. All right, so there's my answer, and notice that did come out the same. Can I hide this again? That did come out the same as this one with the calculator. I put in these parameters for the calculator, and then when we did this one here, still got 79.05. Okay, so either way to do it, it'd be good if you can get a calculator, but also very useful to be able to read these tables if you need them and don't have your calculator around. Okay, good.